Hi everyone, welcome you all to this lecture about CPU scheduling. This is C. Karpagavalli, Assistant Professor, Department of Artificial Intelligence and Data Science, Ramco Institute of Technology, Rajapalayam. In CPU scheduling, we have 6 types of scheduling. First come, first serve scheduling, shortest job first scheduling, round robin scheduling, priority based scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. In this lecture, we are going to see first come, first serve scheduling and shortest job first scheduling with examples. Before going to the topic, we need to understand what is CPU scheduling and why do we need scheduling. In the uniprogramming systems like MS-DOS, when a process waits for any IO operation to be done, the CPU remains idle. This is an overhead since it wastes the time and causes the problem of starvation. The starvation occurs when a process waits for an infinite time to get the resources. However, in multi-programming systems, the CPU doesn't remain idle during the waiting time of the process and it starts executing other processes. The operating system has to define which process the CPU will be given. In multi-programming systems, the operating system schedules the processes on the CPU to have the maximum utilization of it, and this procedure is called the CPU scheduling. The operating system uses various scheduling algorithms to schedule the processes. This is the task of short-term scheduler to schedule the CPU for the number of processes present in the job pool. Whenever the running process requests for some IO operation, then the short-term scheduler saves the current context of the process, also called PCB, process control block, and changes its stage from running to waiting. During this time, the process is in waiting state. The short-term scheduler picks another process from the ready queue and assigns the CPU to this process. This procedure is called context switching. What is saved in the process control block? The operating system maintains a process control block during the lifetime of the process. The process control block is deleted when a process is terminated or killed. These are the things available in the process control block. Process ID, process state, pointer, priority, program counter, CPU registers, IO information, and accounting information. Why do we need scheduling? In multi-programming system, if a long-term scheduler picks more IO-bound processes, then most of the time the CPU remains idle. The task of operating system is to optimize the utilization of resources. If most of the running processes change their state from running to waiting, then there may be a chance of deadlock in the system. Hence, to avoid this overhead, the operating system needs to schedule the jobs to get the optimal utilization of CPU and to avoid the possibility of deadlock. The purpose of scheduling algorithm. First one is maximum CPU utilization, then fair allocation of CPU, then to get the maximum throughput, then to get the minimum turnaround time, minimum waiting time, and minimum response time. Let us see the types of scheduling algorithm one by one. The first type of scheduling algorithm is first come first serve. This is the very simplest algorithm to implement. The process with the minimal arrival time will get the CPU first, which means from the available processes, which process is having lesser arrival time will get the CPU first. It is the non-preemptive type of scheduling. The second type of scheduling is round robin scheduling. In this type, the operating system defines a time quantum that is called slice. All the processes will get executed in a cyclic way. Each of the process will get the CPU for small amount of time called time quantum and then get back to the ready queue to wait for its next turn. It is a preemptive type of scheduling. Shortest job first scheduling. In this type of scheduling, the shortest burst time will get the CPU first, which means from the available processes, which process is having lesser burst time will get the CPU first. It is the non-preemptive type of scheduling. Next type is shortest remaining time first. It is the preemptive form of shortest job first scheduling. In this type, the operating system schedules the job according to their remaining time of execution. Next is priority based scheduling. In this type of scheduling, the priority will be assigned to each of the processes. The higher the priority job process will get the CPU first. If the priority of two processes is same, then they will be scheduled according to their arrival time. The next type is highest response ratio next. In this type of scheduling, the process with the highest response ratio will be scheduled next. This reduces the problem of starvation in the system. The important terms used in the CPU scheduling. FCFS, that is first come first serve. AT is arrival time. BT means burst time, that is execution time. Then WT waiting time. TAT is stand around time. CT is completion time. FIFO first in first out. Then first type of scheduling is first come first serve. This is also known as FCFS scheduling. So in first come first serve scheduling, what we do is to allow the processes to execute in a linear manner. This means whichever process enter the ready queue first, that will be executed first. It shows the first come first serve scheduling algorithm follows the first in first out principle. It can be executed in preemptive and non-preemptive manner. So before seeing the example of FCFS, we should understand what is preemptive approach and what is non-preemptive approach. In preemptive approach, the operating system allots the resources to a process for a predetermined period of time. The process transition from running state to ready state or from waiting state to ready state during the resource allocation. The switching happens because the CPU may assign other processes precedence and substitute the currently active process for the higher priority process. This is the definition of preemptive approach. Then second one is non-preemptive approach. So in this approach, the resource cannot be withdrawn from a process before the process has finished its execution. So when a process, a running process finishes and a transition to the waiting state, then the resources are switched to the other processes. This is the definition of non-preemptive approach. So next is characteristics of FCFS scheduling. It is very simple to implement. It adapts a non-preemptive and preemptive strategy. It runs each process in a order that they are received. Then arrival time is used as a selection criteria for this type of scheduling. So let's see the example for the FCFS scheduling. So first in this table we have given the 6 processes named as P1 to P6. P1, P2, P3, P4, P5, P6 are the number of processes and their arrival time and the burst time are given. So let us solve this example by using first come first serve scheduling in a non-preemptive approach. So already we know the definition of non-preemptive approach. The resources in non-preemptive approach, the resources cannot be withdrawn from a process before the process has finished its execution. That is the definition of non-preemptive approach. So here from the table we need to draw the Gantt chart. So here at time 0 the process P1 arrives. So the scheduler will schedule the process P1 first. So the P1 and the process P1 will be executed for the 9 units of time because the burst time of P1 is 9. So the completion time of P1 is 9 and response time of P1 is 0. After that in FCFS scheduling all the processes are allowed in a linear manner. So the next process will be P2. So P2 will be executed for the next 3 units of time. So the completion time of P2 is 12. That means 9 plus 3. Burst time of P2 is 3. So 9 plus 3, 12. So the next process will be P3. P3 will be executed for next 2 units of time because the burst time of P3 is 2. So from the table we can identify the burst time of each process. So P3 burst time is 2. So process P3 will be executed for the next 2 units of time. So the completion time of P3 is 14. After that P4 will arrive the scheduling. So P4 will be executed for the next 4 units of time. So the completion time of P4 is 18. So the burst time of P4 is 4. So 14 plus 4, 18. So the next process will be P5. So P5 will be executed next 3 units of time. So the completion time of P5 is 21. 18 plus 3, 21. So after that, the last process in the list is P6. So P6 will be executed for the next 2 units of time. So the completion time of P6 will be 23. So from this Gantt chart, we can know the response time and completion time of each processes. So here the process P1 response time is 0 and the completion time is 9. So next process P2, the response time is 9 and the completion time is 12. So next process P3, response time is 12 So this is the response time and this is the completion time. So P3 response time is 12 and the completion time is P4. So the next process will be P4. So P4 response time is 14, completion time is 18. Then P5 response time 18, completion time 21. P6 response time 21, completion time 23. So from this Gantt chart, we can write the completion time of each process. So here, this is the solution for the given example. So here the completion time is for time for each process is written from the Gantt chart. Next, we need to calculate the turnaround time and waiting time. So the turnaround time is difference between completion time and arrival time. So here we have the completion time as well as the arrival time. So from this, we can calculate the turnaround time of each process. So first we take the process P1. So P1 turnaround time is 9 because the completion time is 9 and arrival time is 0. So 9 minus 0, 9. Next process P2. So P2 completion time is 12 and arrival time is 1. So here the turnaround time of P2 is 11. The next process P3. So P3 turnaround time is 13. That is completion time is 14 and arrival time is 1. So 14 minus 1, 13. So next process P4. So P4 turnaround time is 17. Here the completion time is 18 and arrival time is 1. So 18 minus 1, 17. Next process P5. P5 turnaround time is 19. That is completion time 21, arrival time 2. So 21 minus 2, 19. Then turnaround time of P6 is 20. So completion time is 23 and arrival time is 3. So 23 minus 3, 20. So these are the turnaround time of each process. The next is waiting time of each process. We need to calculate the waiting time. So the waiting time is difference between turnaround time and burst time. So here we have the turnaround time of each process as well as the burst time of each process. So from this we can calculate the waiting time. So the waiting time of P1 is 0. So here the turnaround time 9 and burst time 9. So 9 minus 9, 0. So next the process P2. P2 waiting time is 8. So the turnaround time 11 and burst time 3. So 11 minus 3, 8. The next process P3 waiting time 11, turnaround time 13 and burst time 3. So 13 minus 2, 11. So next one P4. So P4 waiting time is 13. So here the turnaround time is 17 and burst time 4. So 17 minus 4, 13. Then next process P5. P5 waiting time is 16. So here the turnaround time is 19 and the burst time is 3. So 19 minus 3, 16. Last process is P6. So P6 waiting time is 18. So here the turnaround time is 20 and waiting time is 2. So 20 minus 2, 18. So these are the waiting time of each process. So from this table, we can calculate the average completion time and average turnaround time, average waiting time of the given example. So here, this is the average completion time. So average completion time is 16.16667. So the total completion time of all the processes divided by the number of processes. Since we have 6 processes in the table, so it is divided by 6. So the average waiting time is 11. So here, the total waiting time of all the processes divided by the number of processes. So average waiting time is 11. So next is average turnaround time. So the average turnaround time is 14.83334. So total turnaround time of all the processes divided by the number of processes. So next we have the FCFS scheduling in preemptive approach. So this is the table. So in this table we have 6 processes P1 to P6. Their arrival time and burst time are given. So let us solve this example by using FCFS scheduling in preemptive approach. So already we know the definition of preemptive. So in preemptive approach, the operating system allots the resources to a process for a predetermined period of time. So this is the definition of preemptive approach. So here from the table we need to draw the Gantt chart. So here at time 0 the process P1 arrives. So the scheduler will schedule the process P1 first for the 1 unit of time. So after that the scheduler check for the process with the least burst time. So from the available processes there are two processes that are having the same burst time P3 as and the P6. P3 and P6 are having the same burst time. It is 2 units each. So if two processes are having the same burst time, the scheduler will be scheduled based on the arrival time. So here P3 arrives before P6, so P3 will be scheduled next. So the scheduler will schedule the P3, so P3 will be executed for the next 2 units of time. So here the arrival time of P3 is 1 and arrival time of P6 is 3. So P3 comes before P6. So P3 will be executed for the next 2 units of time. So the completion time of P3 is 3. So the next process will be P6. So P6 will be executed next 2 units of time. That is the complete burst time of P6 is 2. So the completion time of P6 is 5. 3 minus 2, 5. After that, the scheduler checks for the process with the least burst time from the available processes. So the next least burst time process is P2 from the available processes, because P3 and P6 are completed. So in the next available process is P2. So P2 burst time is 3. So it will be executed for the next 3 units of time. So the completion time of P2 is 8. So the next process is P5. So P5 is having the least burst time comparing to the other processes. So the P5 will be scheduled next. So P5 completion time is 11, because the burst time is 3. So 8 minus 3, 11. So next process will be P4. So P4 burst time is 4. So the P4 will be executed for next 4 units of time. So the completion time of P4 is 15. So next last process is P1. So P1 is having the remaining 8 units of time. So it will be scheduled next. So P1 will be executed for the next 8 units of time. So the completion time of P1 is 23. So this is the Gantt chart for the given example. So here this Gantt chart is prepared based on the FCFS scheduling preemptive approach. So in this Gantt chart, we can find the response time and completion time of each process. So this is a solution for the given example. So here we have 6 processes P1 to P6. Then arrival time, burst time are given. Then completion time we are writing from the Gantt chart. So here the completion time of P1 is 23 and P2 is 8. So from this Gantt chart, we can write the completion time of each process. So the process P1 completion time is 23. Process P2 completion time is 8. Process P3 completion time is 3. Then process P4 completion time is 15. So from this, we can write the completion time of each process: 23, 8, 3, 15, 11 and 5. So after that, we need to calculate the turnaround time and waiting time. So the turnaround time is difference between the completion time and arrival time. So here the turnaround time of P1 is 23. That is completion time minus arrival time. So 23 minus 0, 23. So next one is P2. So P2 turnaround time is 7. So here the completion time is 8 and arrival time is 1. So 8 minus 1, 7. So next is P3. So P3 turnaround time is 2. So completion time is 3 and arrival time is 1. So 3 minus 1, 2. So next P4. P4 turnaround time is 14. The completion time of P4 is 15 and arrival time is 1. So 15 minus 1, 14. So next is P5. So P5 turnaround time is 9. So here the completion time 11, arrival time 2. So 11 minus 2, 9. Then last one P6. P6 turnaround time is 2. So here the completion time is 5 and arrival time is 3. So 5 minus 3, 2. So these are the turnaround time of each processes. Next, we need to calculate the waiting time of each process. So here the waiting time is difference between turnaround time and burst time. This is the waiting time. So here the process P1 is waiting time is 14. Here the turnaround time is 23 and the burst time 9. So 23 minus 9, 14. The next one process P2. So P2 waiting time is 4. The turnaround time 7 and burst time 3. So 7 minus 3, 4. 4. So next process P3. P3 waiting time is 0. Here the turnaround time is 2 and burst time is 2. So 2 minus 2, 0. Next waiting time of P4. So P4 waiting time is 10. So here the turnaround time is 14 and burst time is 4. So 14 minus 4, 10. Then P5 waiting time is 6. So here the turnaround time is 9 and burst time is 3. So 9 minus 3, 6. The waiting time of last process P6 is 0. So here the turnaround time is 2 and the burst time is 2. So 2 minus 2, 0. So these are the waiting time of each process. So from this table, we can calculate the average completion time, average turnaround time, and average waiting time. So the average completion time is 10.83333. So here the total completion time of all the processes divided by the number of processes. Then the waiting time, average waiting time is 5.83333. So here the total waiting time of all the processes divided by the number of processes. Next is average turnaround time. So the average turnaround time is 9.5. The total turnaround time of all the processes divided by the number of processes. So this table clearly shows that FCFS preemptive approach, the average completion time and average waiting time, average turnaround time is lesser than the FCFS non-preemptive approach. So here the first one is average completion time. So in average completion time, FCFS preemptive scheduling is 10.833. Then FCFS non-preemptive scheduling approach is 16.1667. Then average waiting time for preemptive approach 5.83. Then average waiting time for non-preemptive approach 11. Then average turnaround time for preemptive approach 9.5. The non-preemptive approach 14.8334. So next, advantages of FCFS scheduling. This FCFS scheduling is a straightforward approach. It is very easy to implement. Then in FCFS preemptive scheduling, there is a no chance of process starving. The disadvantages of FCFS scheduling. This algorithm has the longer waiting time. Then it favors the CPU over the input-output operations. There is a chance of occurrence of convoy effect in the FCFS scheduling. So it is a since it is a straightforward approach, it is very not effective. So next is convoy effect in the first come first serve scheduling. The convoy effect is a phenomenon which occurs in the first come first serve scheduling. So it occurs in a non-preemptive approach. So in non-preemptive approach, if a process is started execution, then the operating system must complete its execution. Until then, next process does not start its execution. In non-preemptive scheduling, the central processing unit will be completely dedicated till the end of the process and the new process is executed only after finishing the older process. So for example, if first process is larger or its completion time is too high, then this convoy effect is occurred. If a longer process or a longer job takes infinite time to complete, then the remaining processes have to wait for the same infinite time. Due to this convoy effect created by the longer process or job, the starvation of the waiting process increases very rapidly. Due to this convoy effect, the waiting time, turnaround time, and completion time of FCFS scheduling is very high. So this is the biggest disadvantages of FCFS scheduling. Convoy effect is the biggest disadvantages of FCFS scheduling. So next is the shortest job first scheduling. That is also known as the SJF, shortest job first scheduling. So already we know that in FCFS scheduling, we are scheduling the processes according to their arrival time. In shortest job first scheduling, it schedules the processes according to their burst time. In SJF scheduling, the processes with the lowest burst time among the list of available processes in the ready queue is going to be executed or going to be scheduled next. Advantages of SJF: maximum throughput and minimum average time and turnaround time. Disadvantages of shortest job scheduling: it may suffer from with the problem of starvation. It is not implementable because the exact burst time for a process cannot be predictable in advance. So this is the example we have taken. There are 5 jobs named as P1, P2, P3, P4, P5. Their arrival time and burst time are given. So here from the table we need to draw the Gantt chart. So here there are 5 processes P1 to P5. So no process arrives at the time 0. Hence there will be an empty slot in the Gantt chart. So here this from the time 0 to 1 there is an empty slot in the Gantt chart. According to the algorithm, the OS schedules a process which is having the lowest burst time among the available process in the ready queue. So till now, we have only one process in the ready queue. Hence, the scheduler will schedule this to the processor, no matter what is its burst time. So next, P1 will be executed for the next 8 units of time. So here, the P1 completion time is 8. So next process will be P3. So P3 is having the least burst time among the available processes. So next the scheduler will select the process P3. So P3 will be executed for the next 2 units of time. So the completion time of P3 is 10. Here the response time is 8 and burst time of P3 is 2. So 8 plus 2, 10. So the next least burst time process is P2. So the scheduler will select the process P2. So P2 will be executed for the next 3 units of time. So the completion time of P2 is 13. 10 plus 3, 13. So the next least burst time process will be P5. So P5 is having the burst time 8 from the available processes. So here the P5 will be executed next. So it will be executed for the next 8 units of time. So the process P5 completion time is 21. 13 minus 8, 21. So the last process will be P4. So P4 will be executed for the next 10 units of time because the burst time of P4 is 10. So the completion time of P4 is 31. 21 plus 10, 31. So this is the Gantt chart for the shortest job burst scheduling. So here from this Gantt chart, we can we can find the response time and completion time of each process. So this is the solution for the given example. So in this table, we have the 6 processes P1 to P5. So arrival time and burst time are given. The completion time we have written from the Gantt chart. So here the completion time of each process P1, P2 and P3, P4, P5. So here from this Gantt chart, we can write the completion time. So after that, we need to find the turnaround time and waiting time. So the turnaround time is difference between the completion time and arrival time. So here the turnaround time of P1 is 7, 8 minus 1, 7. Then turnaround time of P2 is 10, 13 minus 3, 10. Then turnaround time of P3 is 4, 10 minus 6, 4. Then turnaround time of P4 is 24, 31 minus 7, 24. Then turnaround time of P5 is 12, 21 minus 9, 12. So these are the turnaround time of each process. The next is waiting time. So the waiting time of first process P1 is 0. Here the waiting time is difference between turnaround time and burst time. Here the turnaround time 7, burst time 7. So 7 minus 7, 0. The next second process P2, P2 waiting time is 7, turnaround time 10, burst time 3. So 10 minus 3, 7. The third process P3, P3 waiting time is 2. So here the turnaround time 4, burst time 2. So 4 minus 2, 2. Then next process P4 waiting time is 14 and 24 minus 10. That is turnaround time 24, burst time 10. 24 minus 10, 14. The next process P4, P4 turnaround time 12 and waiting burst time 8. So 12 minus 8, 4. This is the waiting time of each process. So the average waiting time for the given example is 5.4. The total waiting time of all the processes divided by the number of processes. So here we have the 5 number of processes. So it is divided by the 5.4. So next type of scheduling is shortest remaining time first scheduling algorithm. So it is also known as SRTF. So this algorithm is a preemptive version of SJF scheduling. In SRTF, the execution of the process can be stopped after a certain amount of time. At the arrival of every process, the short-term scheduler schedules the processes with the least remaining burst time among the list of available processes and the running process. Once all the processes are available in the ready queue, no preemption will be done and the algorithm will follow as SJF, that is shortest job first scheduling. The context of the process is saved in the process control block when the process is removed from the execution and the next process is scheduled. This process control block is accessed in the next execution of this process. So this is the example we have taken. So here we have six jobs P1 to P6, P1, P2, P3, P4, P5, P6. Their arrival time and burst time are given. So from this table, we need to draw the Gantt chart. So here at a time 0, the only available process is P1. So this is the only available process in the list. Therefore, it is scheduled. So the scheduler will schedule the process P1 first. So the process P1 will be executed for the 1 unit of time. So the next process P2 arrives at a time 1. Since the algorithm we are using is SRTF, which is a preemptive one, the current execution is stopped and the scheduler checks for the process with the least burst time. Till now, there are two processes available in the ready queue, that is P1 and P2. So here the remaining burst time of P1 is 7 and burst time of P4 is 4. So from this two process, the least burst time is P2. So P2 will be scheduled next. So P2 will be executed for the next 1 unit of time. After that, the process P3 arrives at time 2. At this time, the execution of P3 is stopped. The process with the least remaining burst time is searched. Since the process P3 has 2 units of burst time, hence it will be given priority over others. So here the process P3 will be executed for the next 1 unit of time. So after that, the process P4 arrives at time 3. At this time, the scheduler will stop the execution of P4 and check which process is having the least burst time among the available processes. That is P1, P2, P3 and P4. So among these 4 processes, P3 and P4 are having the remaining burst time 1 unit each. Since both are equal, hence the scheduling will be done according to their arrival time. So P3 arrives earlier than P4 and therefore it will be scheduled again. So P3 will be scheduled again. So the next process is P5. So P5 arrives at a time unit 4. So at this time, the process P3 has completed its execution. There is no more in the list. The scheduler will compare the remaining burst time of all the available processes. So here, since the burst time of the process P4 is 1, which is the least among all the processes, hence it will be scheduled next. So P4 will be scheduled next. It will be executed for the next 1 unit of time. So after that, the process P6 arrives at time unit 5. This time, the process P4 has completed its execution. So we have only 4 available processes. P1 having the 7 units of remaining time. P2 is 3 units of remaining time. Then P5 is 3 units of remaining time. P6 is 2 units of remaining time. So the burst time of P6 is least among all the processes. So P6 is scheduled next. So P6 will be executed for the next 3 units of time. Since now all the processes are available, hence the algorithm we are using SRTF. If all the processes available means the algorithm will work same as SJF. So P6 will be executed till its completion and then the process with the least remaining time will be scheduled next. So after that, the process P2 is having the least burst time. So least remaining burst time 3. So P2 will be scheduled next. It will be executed for the next 3 units of time. So the completion time of P2 is 10. After that, the process P5 will be executed for the next. So P5 will be executed for the next 3 units of time. So 10 plus 3, 13. So after that, the remaining time of P1 will be executed next. So the remaining burst time of P1 is 7. So the P1 will be executed for the next 7 units of time. So here the completion time of P1 is 20. So from this Gantt chart, we can find the response time and completion time of each processes. So this is the solution for the given example. So from the Gantt chart, we can write the completion time of each process. So here we are writing the completion time 20, 10, 4, 5, 13 and 7. So from this Gantt chart, we can write the completion time of each process. P1 is 20, then P2 is 10, P3 is 4, P5 is 5, then P4 is 5, P5 is 13, P6 is 7. So this is the completion time of each process. Next, we need to calculate the turnaround time and waiting time. So the turnaround time is difference between the completion time and arrival time. So 20 minus 0, 20, then 10 minus 1, 9, 4 minus 2, 2, 5 minus 3, 2, 13 minus 4, 9, 7 minus 5, 2. So this is the turnaround time of each process. The next is waiting time. So the waiting time of each process is calculated difference between the turnaround time and burst time. So 20 minus 8, 12, then 9 minus 4, 5, 2 minus 2, 0, then 2 minus 1, 2, then turnaround time 9 minus 3 burst time, 9 minus 3, 6, then the waiting time of P6 is 0, that is the turnaround time is 2 and completion time is 2. So 2 minus 2, 0. This is the waiting time of each process. Next, the response time. So this response time also we can write from the Gantt chart. So here we have the response time of each process. So from this Gantt chart, we can write the response time of each process. So next is the average waiting time of the given example. So average waiting time is 4. Total waiting time of all the processes divided by the number of processes. So this is the about the shortest remaining time first scheduling algorithm. Thank you all. Thanks for watching.